In this video, we're going to create a simulation of the kinematics of a parallel mechanism. Anytime we're trying to derive complex equations, for example, forward and inverse kinematics, creating a simulation is a good way to check our work and see if our answers make sense and if we're correct. So start by opening idle and get a shell like this, and the first thing we need to do is check to see if you have matplotlib installed. Matplotlib is a Python package for creating plots, and that's how we're going to look at our output in this simulation. So in the shell here, type in import matplotlib and hit enter. Now, if your output is like mine, you just went to another set of little arrows here, then you're good to go. You have matplotlib installed. But I think that most of you at this point do not have matplotlib installed, and so you'll get some errors here. If your output is like mine, that you do have matplotlib installed, you can skip ahead in the video. If you got some errors here, red text, keep watching at this point, and I'm now going to show you how to install matplotlib. On your computer, I'm assuming you're using a Windows computer, down here in search, type in CMD, and then click on command prompt. After you have a command prompt window open, the first thing you need to do is set your path to where Python is installed. So do cd space c:\python27. That's the default install location of Python where we installed it way back in Robotics 1. So hit enter and it'll take us to the cpython27 directory, and now we're going to type in pip space install space matplotlib. Now before you hit enter, make sure your computer is connected to the internet. Once you're sure you are connected to the internet, hit enter here and watch what happens in the output. If you get no errors, just all white text, then you're probably good to go. But if you got some kind of an error here, red text, there's one really common source of that error, and I'm going to show you how to fix that now. So if you got an error when you did pip install matplotlib and hit enter, I'm going to show you now something to try to fix that error. Open up a Windows Explorer window and go to your C drive. And go down to Python 27 and double click. Then find the folder called lib, like this, double click there. Then go down to Site Packages, double click there. Now find the folder here that's called numpy, like this. And cut that folder. So Control X on your keyboard and then paste it someplace else so that it disappears here and you no longer have the numpy folder. Once you no longer have the numpy folder, go back to your command prompt and try again. Pip install matplotlib and hit enter. More likely than not, it will now succeed and successfully install matplotlib. Once you think you have it successfully installed, go back to your Python shell idle and close it. Then open the shell again. And now we're going to test our install. So we'll do import matplotlib and hit enter. And hopefully now you go to these little arrows, meaning that it is successfully installed. Let's also check and make sure that we didn't lose the install of NumPy. So do import NumPy, hit enter, and make sure that that succeeds as well. If both of these imports succeeded for you, let's go to File and then click on New File to get a script window, and we're going to write some code. We need to start out with two import lines. We're going to import NumPy as NP. Then we'll import matplotlib.pyplot as PLT. Now the first thing we'll do to make our simulation is to input the desired position and rotation of the platform. Now we call the vector that goes to the center of the platform P. So we'll do P equals np.array and then we have square brackets, and we'll put in our X position, which I'm just going to put 0.0 here. In a moment, we'll go back and talk about what these numbers should actually be. And then I'll do comma 0.0. So right now I'm just filling in zeros, but we'll go back and change these values later. Now R is the rotation matrix of the platform. So we'll do np.array square brackets. We're only going to simulate a two-dimensional platform for now. So our rotation matrix is only going to be 2 by 2. And right now I'm going to put in a rotation that is no rotation. So I'll do the 2 by 2 version of the identity matrix. 1.0, comma 0.0 is the first row. Then comma 0.0, 1.0. Next, we'll put in our design variables. The design variables are the vectors that we've been calling A and B. The A vectors are the vectors from the center of our base frame to the point where the bottoms of the legs are attached. So we have an A1, and also here I'm just going to put 0 in for all of these values. Now we have the vectors B1 and B2. B1 and B2 are the vectors from the center of the platform to where the tops of the legs are attached, measured in the frame that is attached to the platform. I'll just fill in zeros for these. Finally, we'll calculate the outputs. The outputs are the vectors S1 and S2. These are the vectors from the bottoms of the legs to the tops of the legs, and the lengths of these vectors will be what we'll send to our controller because we're controlling the lengths of the legs. So let's calculate the S1 and S2 vectors. We'll use np.dot to take the dot product of the rotation matrix and B1 for S1 Now, since the lengths of the legs are what we would actually send to our microcontroller, let's go ahead and calculate the lengths of the legs S1 and S2. We take the square root of S1, the first element, squared. And the way we square something is we put two multiplication signs, two asterisks, and then the power we want to raise that to. That's how we do a square in Python. And then we'll take the second element of the vector and square it. And then we'll do the length of S2 also. Okay, finally, let's plot this result. We'll do plt.plot. Now, we need to have one vector in square brackets that gives a list of the x positions that we want to plot. So here are the x positions we want to plot. We want to start at point A1. Then the next point we want to go to will be S1, the first element, its x position, plus A1. This is the position of the top of the leg. So A1, 0 is the position of the bottom of the leg. S1 plus A1 is the position of the top of the leg. The next position we want to plot is the center of the platform, and that is position P. Next, we want to go to the top of the second leg. And now we want to go to the bottom of the second leg. This will plot our whole parallel mechanism. So the next thing we need to do is give the y vector. The y vector is going to be exactly the same as the x vector, except we'll put a 1 in here instead of 0. So I'm going to copy this vector, paste it, and we'll do 1, the y position instead. And I left out some parentheses here. We need to have parentheses everywhere we have np.array. So let's go back in here and fill in opening and closing parentheses. Now fill in values for P, A1, A2, B1, and B2 based upon the diagram that we have defining these things. And once you've filled in those values, run this and take a look at your plot. After I've filled in values and run my code, my plot looks like this. Your plot might look different than mine, but it should look like this, a platform with 2 legs. Once you have this working, let's go back into your code and we're going to animate this plot to show how we can calculate the leg lengths when we translate the platform. Okay, back in our code, we're going to add some lines to animate our platform. First, I'm going to create a figure. Then I'm going to turn on a function that allows interaction with the plot. Then we'll turn the hold off by setting plt.hold false. This will make it so that every time we plot a new plot, it will overwrite the old plot. And this will allow us to plot things in a row over time to make it look as though our plot is being animated. Now, right before we calculate the outputs, the leg lengths, let's make a loop. I'll create an index called I, set it equal to 0, and then we'll run this loop as long as I is less than 100. And then I do colon because that's how we start a while loop in Python. Now I need to find everything that we want to be inside of this loop. And the things that we want inside are these things right here. So I'll highlight them and then hit Tab to indent them so that all of these lines are inside the while loop. Now let's add a couple of additional lines inside of this while loop to plot our animation. And actually we want this plot line to be in the loop also. So I'm going to put this plot here, but I'll leave the plt.show outside. Now every time we plot a new plot, we'll make the figure update by doing plt.draw. And then we need to have a little bit of a pause so that there's some time for our new plot to be on the screen. We'll do plt.pause, and then we'll give a number of seconds that we want this plot to stay on the screen. Let's do 0.01. Next, we need to increment I so that this won't be an infinite loop. And now the last thing I'm going to change here is what I want to be different every time we go through this loop. If I want the platform to translate, I can do that by incrementing the first vector element of the P vector. The P vector is the one that goes to the center of the platform. So if I take the X component of the P vector, and every time through this loop I make it a little bit bigger, let's do something like 0.04, then every time we go through this loop, the platform will translate 0.04 to the right. Now, in addition to plot.show at the end here, I also need to turn off my plot interaction. So we'll do plt.ioff, interaction off. And now let's go ahead and run this code. As the code runs, you'll see the platform moving off to the right into a new position. Notice how the lengths of the two legs are changing as the platform translates. We could print the values of the lengths of the legs so that we can check to see if it's working correctly. Let's go back into our code. Down here we've already calculated length S1 and length S2. Let's do print length S1 equals, and let's print both on the same line. Let's run this again. This time, as the code runs, you can see the length of the two legs being printed out to the screen. And you should notice that the length of leg 1 is growing longer, while the length of leg 2 is growing shorter. Now, if you've gotten this working, there's one more thing I want you to do to turn in for today's submission. I've shown you how to get the platform to translate in our simulation. Can you figure out how to change the code so that we get the platform to rotate instead? I'll give you a little hint. Up here in our code, you've already filled in your own numbers for the P vector and for the A1 and A2 vectors and the B1 and B2 vectors. But right here is the rotation of the platform. We've set this rotation to be the identity matrix so that the platform has no rotation relative to the base frame. Can you replace this rotation matrix with not constant values, but variable values that use the variable theta, the rotation of the platform? Then take this rotation matrix and put it inside the loop. And instead of changing the value of P0 here, change the value of theta, the angle of rotation of the platform. I'll show you an example of what your final video should look like. Once you get your code working to animate the rotation of the platform, that's what you should show me to get checked off today.